physical quantities are divided in two categories: scalar physical quantities and vector physical quantities, or simply we can say scalars and vectors. Scalar physical quantities are such physical quantities which can be represented with the help of their magnitude only. Magnitude means its value. And vector physical quantities are such physical quantities which can be represented or which can be explained with its magnitude as well as direction. See the example: mass, temperature, energy. Suppose we say mass of a particle is 1 kilogram. So yes, now perfectly explained. Day to day life માં આપણે એવું બી ઓબ્ઝર્વ નથી કરતા કે mass is 1 kilogram in east direction, and if you take that particle in west direction and then measure the mass, then it is changed. આવું કોઈ દિવસ હોય છે? નથી હોતું. માસ માટે કીધું બસ આટલું માસ છે, ધેટ્સ ઇટ, પતી ગયું, કે આ ડાયરેક્શનની કોઈ જરૂરત જ નથી એની અંદર. એટલે perfectly explained with the help of its magnitude, or we can say simple value. But some physical quantities are such that which can be explained by their magnitude as well as direction. Directions are must in that. Suppose we say velocity, acceleration, force. હમણાં જ આપણે આગળ એક્ઝામ્પલ લીધું. મેં તમને કહ્યું કે પાર્ટિકલ ઇઝ મૂવિંગ વિથ વેલોસિટી 5 સેન્ટીમીટર પર સેકન્ડ, અને 2 સેકન્ડ પછી એની પોઝિશન લોકેટ કરો. ના થઈ શકી આપણાથી. વાય? કારણ કે ડાયરેક્શન મેન્શન નહોતી થયેલી એમાં. ક્લિયર? So some physical quantities can be explained with the help of their magnitudes and direction, are called vectors. These are some examples. Now, scalar quantities are represented simply by their symbols. We use symbol for mass, that is m. Simply you can use m. For temperature T, for energy E, that's it, nothing to do with it. But vector physical quantities are represented with specific symbols. Which type of symbol? See here. For the physical quantity, the basic symbol that we use, that will remain as it is. For velocity, we use V, then we have to use it V. For acceleration, we use A. For force, we use capital F. So we have to use those symbols as it is. But when we represent it as a vector, then above the symbol of that physical quantity, we have to place an arrow. And this arrow, that should be towards right side. Left one nahi batavano. This is the symbol of vector quantity. When on the symbol of any physical quantity arrow is placed, it implies that now that is the vector physical quantity. Clear? Then magnitude or the value of a physical quantity is symbolically represented by its symbol in mode. So when the symbol of the vector physical quantity is placed in the mode, then we can say that is magnitude of that vector physical quantity. Or simply, without the symbol of vector, means this arrow represent that physical quantity, then also it is called magnitude of that physical quantity, or simply value of that physical quantity. જેમ કે આપણે આગળ કહ્યું હમણાં કે it is moving with velocity 5 centimeter per second, તો એની વેલ્યુ થઈ, એમાં કોઈ ડાયરેક્શન મેન્શન કરેલી નથી, એટલે એને મેગ્નિટ્યુડ પણ કહેવાય અથવા તો વેલ્યુ પણ કહેવાય. તો આ રીતે રિપ્રેઝન્ટ થાય. Now here in practice, we require the combinations of physical quantities. We require combinations of physical, in practice, we require combinations of physical quantities. Now, combinations of physical quantities, that is called algebra of physical quantities. But for scalars, or we can say for scalar physical quantities, there is no special algebra. For scalar physical quantities, algebra, that is our conventional one, as we study in mathematics. Suppose we say mass of any one particle is 1 kilogram, mass of another particle, that is 2 kilogram. Then if we combine these two particles, then the total mass of the system will be how much? 1 plus 2, that is equal to 3. That simple algebra that we have to use for scalar physical quantities. But for vector physical quantities, there is a special algebra, and that we have to study. Algebra of the vectors physical quantities, that is nothing but the summation of vectors, subtraction of vectors, and multiplication of vectors. This summation, subtraction, and multiplication of vectors, that is nothing but special type of combinations of physical quantities. Or in other words, we can say when more than one vector physical quantities are acting at that time, what is the final result? That is vector algebra. Okay? So, divisions of vectors are not defined. We have to think about the summation, subtraction, or multiplication of vectors. Again, multiplication of vectors, that is divided in two parts. Scalar product of vectors and vector product of vectors. All these things we will discuss in detail later on. નહીતર અત્યારે આપણને પાછું load feel થશે. Okay? Now see how any vector can be represented graphically. So graphically the vector is represented by an arrow. Okay? Now how we have to place the arrow? So arrow that should be placed in the direction of the effectiveness of that physical quantity. Suppose velocity of the particle is in this direction, then arrow should point that particular direction. Suppose your particle is moving in this particular direction, then the velocity vector that we have to represent pointing this direction, like that, right? So this arrow should point the direction of the effectiveness of that physical quantity. And the starting point of this arrow, that is called tail of the vector. End point at the arrow, that is called head of the vector. Now, direction you can easily understand with the help of this arrow. What about magnitude or the value? So here you can't prepare the arrow with arbitrary length. ગમે તેટલી length નો arrow ના બનાવાય. The length of the arrow that we have to keep in proportion to its value, or we can say magnitude. How? So here we have to prepare proper scaling. Suppose any object is moving with velocity 100 kilometer per hour. 100 kilometer per hour. In X direction. In positive X direction. Then if we want to represent this particular velocity by a vector, then suppose here we prepare the scaling like this. 1 centimeter equal to 10 kilometer per hour. તમે જ્યારે 9th 10th માં ગ્રાફ ડ્રો કર્યા ત્યારે આવું સ્કેલિંગ તમે સમજ્યા હતા. Suppose we take 1 centimeter, that is equal to 10 kilometer per hour. So corresponding to 100 kilometer per hour, we have to take 10 centimeter. So now prepare a vector of length 10 centimeter. So draw a line of 10 centimeter on x-axis, or we can say parallel to x-axis, and place arrow pointing the positive x direction. Then we can say, yes, now the velocity vector is prepared. So in this way, the vector is represented graphically.